All right, so today we're going to do lesson 1-4, which is rewriting equations. But first of all, here's your warm-up to start the day. Basically the algebra skills part from lesson 1.3, so you may already have this done. And here are the answers for lesson 1.3. All right. All right, so do we recall solving for y? All right. So we want to solve the following equations for y. So you may remember how to do these. So let's just kind of get right into it. So we want to solve for y. So whenever we're solving for y, that means we're trying to isolate it, just like any other equation. It's just that we're not going to get a number for an answer. We're going to get an answer that has numbers and variables in it. Right, so to solve for y here, we're going to get rid of the 8x first. So the thing to remember is that I'm always going to put the variable first, so this is going to be negative 8x plus 18. Do not add them together. Those are not like terms. You cannot put them together. So do not add them together. All right, then we're going to divide by negative 2 because we want to get y by itself. All right? So we have negative 8 divided by negative 2 is 4x. And 18 divided by negative 2 is negative 9. So make sure that when you're solving them that you still have your variables in there and you don't combine terms that are not like terms, because that seems to be the biggest problem. All right? So number 2, still solving for y. So in this case, I got all of them on the same side. So instead of moving everything else, I'm actually going to move the y term to the other side. So since it's negative 5y, I'm going to add 5y to both sides. So we get 3x plus 11 equals 5y, and then divide by 5. So y equals, and I want to write this as two separate fractions, 3/5 x plus 11/5. So the 5 is our common denominator for both of them. So we got to keep the 5 with both of them as we write it. All right? So let's do 3 and 4 also. All right, keep going. Number 3, going to subtract x from both sides. So we get negative 3y equals negative x plus 14. And we want to put that variable first and divide by negative 3. So we get y equals 1/3 x, all right? Negative 1 divided by negative 3 minus 14 over 3. All right, so you go ahead and pause it and do number 4, and then you can check to see if you have the answer correct. All right, so with number 4, we are going to subtract 7 first. So we get the 2y by itself. So we get x minus 7 equals negative 2y, and divide by negative 2. So we've got, remember this is a positive 1x, so we get negative 1/2 x, and both the 7 and the 2 are negative, so positive 7/2 equals y. All right? So the big thing is, remember, just that I want to get the y by itself, and that I can only combine like terms, so if I'm adding or subtracting 7 from x, then it's x minus 7. It's not negative 7x or something else. All right, so don't forget that. All right, here's some commonly used area equations, and we're going to solve them for the specific variable that's in the parentheses. And so I'm going to do numbers 5, 6, and 7, and then you go ahead and do numbers 8 through 12, and I'll put the answers up so you can make sure you've done those correctly. All right, so we're solving for b here. First of all, a equals 1/2 bh, so this is the area of a triangle. So the first thing I want to do if I'm solving for b, I need to get rid of the 1/2 and the h. So I'm going to multiply both sides by 1/2, first of all, to get rid of that 1/2. So I'm going to multiply by 2. All right. So we get 2a equals bh, and we're solving for b, so we divide by h. So b equals 2 A over H. Now make sure that when you're doing these, if it's a lowercase letter, use lowercase. If it's uppercase letter, use the uppercase. All right. Number 6, A equals pi r squared. So this is the area of a circle. So for solving for r, we need to get rid of pi first. Okay. So we get r squared equals A over pi. And remember, if we're trying to get rid of something that's squared, we're going to take the square root of that. So we take the square root of both sides. And big thing to remember is you get a plus or minus square root of A over pi. Now this is a situation where we're going to leave, we'll just go ahead and leave the pi in the denominator in the radical. We'll leave it that way. All right? Okay. Number 7. Area equals 1/2 B1 plus B2 times H. So this is the area of a trapezoid. All right. So similar to number 5, the first thing we're going to do is get rid of the 1/2. We're solving for B1, but we want to get rid of everything else before that. We don't want to distribute the 1/2 and distribute the H and then try to solve. We want to do it before that. So we're going to multiply by 2, divide by H, and then we'll get rid of the B2 so that we're solving for B1. Right? So first we're going to multiply both sides by 2. So we get 2A equals B1 plus B2. Those are bases, so base 1 plus base 2. All right, and then we're going to divide by H. So we get 2A over H equals B sub 1 plus B sub 2. And we're trying to solve for B sub 1, so then we're going to subtract B sub 2. Oops. So when we do this, we get that B sub 1 equals 2A over H minus B sub 2. All right, and we'll just leave it that way. All right, so the big thing is that when we have parentheses like we did in this one, we don't want to distribute everything and do the multiplication. We want to get rid of the things that are outside of the parentheses first, and then we can work on the inside of the parentheses. All right, so you go ahead and do numbers 8, 9, 10, 11, and 12. And so pause the video, and I'll put the answers up here. And so after you get done doing them, you can start the video back up again, and it'll show you those answers. Okay, so here's those answers from 8 through 12. Hopefully you did them right. You just have to make sure that you're moving things at the right time. So for like number 9, we're solving for B, so we just need to subtract mx. Now number 10, 11, and 12 become a little bit trickier, but you've got to make sure you take your time with them, work through them. Number 10, you're solving for C, so we subtract 32, and then we multiply by the reciprocal, 5/9. Number 11, we're solving for Z, but the first thing we've got to do is get rid of the R. So your first step for number 11 would be to multiply by R. So then you get x plus z minus w equals 1. And then you just have to move the x and the w to the other side. All right. All right, so we have a word problem here. It says the Pythagorean theorem of baseball is used to predict the number of wins a team will have when given the number of runs scored, the number of runs the opponent scored, and the total number of games played. All right, so here we have this formula. W over T is approximately R squared over R squared plus A squared. And the first thing I want us to do is I want us to solve this for W. All right, so to solve it for W, we're just going to multiply both sides by T. So W is approximately R squared T, because that just goes to the numerator then, and R squared plus A squared in the denominator. Right? So they actually, there's a book written by Bill James is the guy's name, and if you've read or if you've seen the movie Moneyball, then this is the big formula that they use in Moneyball. Right? So in 2012, the Yankees scored 804 runs, while their opponent scored 668 runs throughout 162 games. Estimate the number of wins the Yankees had. The actual number of wins for the Yankees in 2012 was 95. All right, so we're trying to find W. All right, and R is the number of runs that their team will score. Okay, so the Yankees scored 804 runs. So we put 804 squared for R. And number of runs their opponent scored is A. So this is plus 668 squared in the denominator. And T is the total number of games they played. And so they played 162 games, so we're going to times 162 here. All right, so we'll take our calculator and we'll figure out how many wins this estimated for the Yankees in the year 2012. Right, so I'm going to pause it. So according to the formula, the Yankees would have won 95.8 games, so that was really close. So this is approximately 96. So it's very close to the number of wins they had in the year 2012. So that's a pretty good estimate. All right. So you go ahead and do number 15. Total number of miles a honeybee can fly in its lifetime. And I will put the answer up for this one also, so you can do it. And then you can check it. And then your assignment is to do the rest of pages 15 and 16 then, whatever you don't have done. Okay, so here's your answer. Make sure you do write a sentence about this that tells what that number means. And I'm sure hopefully all the homework will go just fine. The rest of the packet will go fine for you. All right?